Hello, my name is Megan Shipe from Longwood University, and I will be presenting on the origin of blue glass beads discovered at an archaeological site known as EYREVILLE. This research was funded by the National Science Foundation. So what is EYREVILLE? Well, as I said before, EYREVILLE is a 17th to 19th century archaeological site located in Northampton, Virginia that sits on the Chesapeake Bay. This is an overhead view of EYREVILLE, and this arrow here points to where the blue beads were found. It is a place dubbed the tree hole because the current owner was pulling out a tree and uncovered a number of artifacts. All of the beads were pulled out of this feature, and this is the tree hole, and date to the 17th century, so the 1600s. We had a total of 35 beads, and these are just some examples of some of them that we looked at, and as you can see, they are quite small. This research was primarily concerned with determining origin of EYREVILLE's blue glass beads, and in my own research, I found two likely possibilities of that. One of which is a Venetian origin, so Venice, Italy, and the other is the Netherlands, specifically Amsterdam, although some glassmaking factories have been found elsewhere in the Netherlands, including in Haarlem and Rotterdam. My hypothesis is that the beads are of Dutch origin because of historic documentation of trade between EYREVILLE and the Dutch during the mid-1600s, which is also the date that we have for the beads. Several Dutch artifacts have also been found in the same context or area as the beads, and they date to a similar time period, suggesting a similar origin. The question then becomes, how do we find out where these beads were made? And the answer to that is chemical analysis. I will get into that in a little bit, but first I'd like to give you some context on who might be using these beads and for what purpose. So there are three groups to look at here, and those are Native Americans, Africans and African slaves, and English colonists. Starting with the Native Americans traded their goods with colonists for European glass beads and would often adorn themselves and their clothes with these beads. Interestingly, Native Americans also buried their dead with beads, and not just glass ones, but their own shell, bone, and ceramic beads as well, indicating a ritual significance given to beads in general. Moving into Africa, blue beads were worn as jewelry or sewn into clothing as charms to protect people from evil spirits. And this is a tradition that was adopted by the slaves in the colonies, who would occasionally pass down bead heirlooms through their families. Sometimes beads would be given to slaves by enslavers, and oftentimes slaves would steal blue beads for themselves as well. Finally, the colonists, outside of trade with Native Americans, would sew beads into clothing and purses to adorn themselves and their goods, as you can see in the picture here. In testing the beads, a number of archaeological methods were employed, including looking at shape, which was tested using a method where a detailed description is listed and then compared to your bead, and then given a corresponding label in both an official term as well as a common name term, so something along the lines of donut or undecorated tube, for example. Color was tested with a Munsell bead color chart, which has color swatches that you can actually hold a bead up to and then compare it and label in both a common name, such as sky blue or ultramarine, as well as a numerical value. Size in the terms of length was measured along with decoration, and then diaphaneity is just the technical term for opaqueness, so whether a bead is translucent, transparent, or opaque, and this was tested by shooting a light up from underneath the bead to see how much light would pass through. Manufacture type just refers to how the glass was made into a bead. So for us, our main concern was drawn versus wound, and again, very simply, it is just how the bead is made. In order to determine origin, we use something called XRF. XRF, or X-ray fluorescence, uses radiation to read individual elements in a substance. In this case, it was the glass beads. This was actually a collaboration between the chemistry and archaeology departments at Longwood University. Our hypothesis is that certain elements or chemicals are unique to a specific area, so we should be able to tell where a bead came from based on what elements we find in the glass. So we used a portable XRF, which is what's shown here, and we placed a bead on this small strip here, and then placed a lead line cap on top of that, because again, we're dealing with radiation. And then we run the machine and it reads the elements and feeds it into a software program for qualitative results. The way this works is that the radiation knocks off an electron from an element's electron shell, and the time it takes for that electron to return to the shell tells the machine what element that is, and it does this for multiple elements all at once. So we actually got some really interesting results from the XRF analysis. We found elements such as silicon and potassium, which we expected, because both of these elements make up glass as a substance. We also found cobalt, which again we expected. Cobalt is a colorant, and colorants, as the name might imply, are elements or chemicals added to glass to change its color. Cobalt, when added to glass, makes a blue color. So, when dealing with blue glass beads, we entirely expected cobalt, and we found quite a bit of it. Another expected element that we did find was antimony. Now, antimony is what's known as an opacifier. Opacifiers are elements or chemicals added to glass to make it more opaque. For example, we have one entirely opaque glass bead that has the highest level of antimony. There were, however, some elements that we did not expect, including bismuth and selenium. And these elements, we think, will help develop new methods for future research into bead origin determination. After all of the analysis was done, I did not find an origin for the beads. However, this is not a negative thing, because along the way, I think that we found some new methods for standardization of determining origin of glass beads. One of the interesting things to come up during this research was the presence of unexpected elements found using the XRF. For example, bismuth was found in our beads, but it was either left out of or not found in previous researchers' studies. Cobalt, as I mentioned before, makes glass blue, so we knew we were going to find that. But, as it turns out, bismuth and cobalt can be found alongside one another in some mines. So this means that bismuth was probably added accidentally along with the cobalt. But in the future, we may be able to link trace elements such as bismuth that typically are found alongside elements that we expect, like the cobalt, to specific mines where individual countries may have been receiving their glass-making materials. In this way, we may be able to form a standard for origin determination for glass beads. I think this is an important path to follow for future research, and it's something that could further our understanding into glass bead origin and may even lead to new ideas or methods that bring us closer to a valid and reliable standard of practice for bead origin determination. I just want to thank you all for coming to my presentation, and please enjoy the rest of your day.